Alright, looks like our video is going to be on inequalities. Some word problems. Looking at the test, looks like we're going to need some more practice with solving inequalities anyway, so I thought this would be perfect. So, this particular word problem, and I happen to be filming this at home, and my dog is whining, and my son Ari might come over and say hello. So that's the background noise. So this problem is about Jerome. Okay, and we are trying to come up with, it looks like, write an inequality, blah, 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 then solve the inequality, interpret the solution. So, the inequality we're going to be coming up with, so let's see if we can figure this out. So, Jerome wants to spend no more than 16 bucks at the Family Fun Center. He doesn't want to spend, he wants to spend no more than $16. So right there in my mind, I already have an inequality for me. I'm going to go ahead and let my dog outside. So hold on a memento. Alright, I'm back. Okay. So Jerome wants to spend no more than 16 bucks at the Family Fun Center. Admission costs $3.25. And each round in the batting cages costs $1.50. Use the numbers and symbols to write an inequality that shows how many rounds n, so n represents the number of rounds, in the batting cages Jerome can buy. Then solve the inequality and interpret the solution. So when I'm looking down here, it's asking for the inequality. I have to use this stuff to fill in the blanks of the inequality, and it's supposed to be something plus something times n, and then a circle, which must mean I put the inequality there with something over here. Okay, what are we thinking? Maybe you try it. You try it. Plug in the blanks, what you think. Pause the video. See if you can figure out what goes in the blanks. And I'm going to start in here. So, I know that when he walks into the Family Fun Center, no matter what he does in the batting cages, it is going to cost him a certain fee just to get in. And how much is that? $3.25. So he's going to have to pay $3.25 no matter what. But he wants to go in the batting cages. So he's going to do something else. So I'm going to put and he wants to do something else. It says each round in the batting cages costs $1.50. Each round. Right there, each represents in my brain multiplication, so that's why I see this multiplication by n, because every time, no matter how many rounds I do, each round is how much? $1.50. $1.50. So if I plug in 1 here, I will have only spent $1.50. If I plug in 2, now I'm double the $1.50 and I'm at $3, and so forth. And then, the inequality there. The inequality, well, this whole thing, he doesn't want to spend any more than 16 bucks. No more than $16. So this whole thing has to be something compared to 16. So can it be, is it supposed to be less than, greater than, less than or equal to, or greater than or equal to? So it's like your mom saying, if you go to City Market, you cannot spend more than 16 bucks. So can you spend 16 bucks? Yes. So I'm going to put an equal to. Can you spend more than that? Greater than that? No! So it has to be less than or equal to 16 bucks. So there is my inequality representing the situation. And now it says to go ahead and solve it. So now we're going to go ahead and solve this inequality. So I'm going to rewrite it without all my added on stuff. So I had now I have to start over. Dang it. Okay, I had $3.25 plus $1.50 for each round at the batting cage. Has to be less than or equal to 16 bucks. First step, I'm going to use the addition property of equality. And I'm going to subtract $3.25 And so now I will be left with 150 per batting cage. So what does this mean? Like in the real world, in this solution, or in the context of the problem. So this means he has the $16 to use. He now has come into the Family Fun Center and spent $325 on admission. So how much does he have left at this point? So some of you could do this in your head and do $16 minus $325. If not, just write it out. Take and borrow. So I'm at 16. That makes no sense. 5, 4. What is that number here? A 5 minus 3 is 2. So I'm at $12.75. All right, now to get how many rounds of the batting cage he can do, I need to get rid of a multiplication by 150. So I'm going to use the division property of equality and divide by 150. So I want to know how many 150s are in 1275. So I'm going to go ahead and divide that out. So I'm at 1275 divided by 150, or 1.5. Move the decimal there, move the decimal there, bring it up. 15 doesn't go into 1, doesn't go into 12, it does go into 127. How many times? So I'm just going to try maybe 9. That's 135, so it's a little too much, so I'm going to go 8. 15 times 8, 0, 4, 12, 120. So I'm left with 7, bring down the 5, 15 into 75. Do you know that one off the top of your head? 15 times 5, 75. Perfectly. So I get an answer of n has to be less than or equal to 8.5. That's my solution that I get. Now, what does it actually mean? Well, I can't go to the batting cage and say, I just want a half round. So really, I'm going to change my solution to n has to be less than or equal to 8. So I can do up to, my interpretation of this would be what? That Jerome can go into the Family Fun Center and he can go up to 8 rounds, but no more than 8 rounds in the batting cage if he wants to spend no more than $16. Okay, so this was a word problem that we worked through and interpreted the solution, and this is something that you could possibly see on the new test known as the PARC. Okay, so get ready to work on some more word problems in math on Monday with inequalities. Okay, see you then.